Hello everyone. Our application monitors sea surface temperature, CO2 levels, and salinity using remote satellites and a refractometer in real time. With this data and data from pre-industrial levels in 1957, we can analyze whether current conditions need to be addressed. If this is the case, then a suggested treatment plan is provided along with species that are sensitive to these conditions and could suffer population loss. So right here we see the current temperature, sea surface temperature, and then this is a expected temperature from the pre-industrial levels. And here are the CO2 levels, and then the expected CO2 levels. Here's the current salinity. In part 35 parts of 1,000 is a expected salinity. And then here are all of the species that are endangered. So if the conditions happen to be something that they are sensitive to and could suffer population loss from, then our application will mention that. And then here is how we implemented the range of what the optimal temperature is, and if it meets those standards. If it doesn't, then it's categorized into specific categories. The same goes for CO2 as well as salinity. And then once our program assesses that information and what the levels are compared to what they need to be, then we can provide a customized plan on that current data. So if the sea surface temperature is at a very crucial level, if the temperatures are at a high level, then we would suggest a cooling infrastructure for that targeted area to combat that high temperature. If the CO2 levels are too high, then we would provide a detailed plan based on the acidification. So by that time, the coral is already being impacted by acidity, and the species are being impacted as well. So we would recommend coral restoration using coral nurseries epigenetic modification, which is basically kind of mutating the coral to be able to withhold in these conditions. So it's basically kind of fast forwarding evolution for specific coral species that are sensitive to these levels of pH from the high CO2 being absorbed. And if it's high salinity, then we will notify the user of the high abnormal levels. And we also have sensor testing to detect if it's faulty or not, if the data does not match up to what is correlating. So if it's a low CO2 and a high temperature, then those don't match biologically, because a high temperature correlates to a high CO2, and then vice versa, because as the CO2 is being absorbed into the ocean, the temperature is. Okay, so here's our program after I've run it. So let's see what it's suggesting to us. So it says the sea surface temperature is at a crucial level. Okay. So it suggests a regional scale cooling infrastructure, and CO2 is also at a high level. Coral restoration is suggested through the forms of epigenetic modifications, marine permaculture, and coral nurseries. And then it says the current saline levels are fine. Okay, so because of the CO2 and the high sea surface temperature, these species are at a high risk due to their sensitivity to those conditions. And so here's our full report.